Hello everyone. In our last video, we discussed about what is characteristic equation and what is the properties of eigenvalues and what do you mean by eigenvalues and eigenvectors, and followed by we have solved few problems in the previous topics. Now I headed to solve the problems in the eigenvalues and eigenvectors. So first I will read the problem, then I will explain how to solve it. Find the eigenvalues and eigenvectors of the matrix 7 minus 2 0 minus 2 6 minus 2 0 minus 2 5. So here we have a 3 by 3 matrix. Here we need to find out what is the eigenvalues and eigenvectors of the 3 by 3 matrix. Okay, there are three steps. In step 1 we need to find out what is the characteristic equation. So already we have discussed about how to find the characteristic equation for 3 by 3 matrix. By help of that concept, I am going to find out what is the characteristic equation for this 3 by 3 matrix. First, let us write the general formula of the characteristic equation for 3 by 3 matrix. It is lambda cube minus d1 lambda square plus d2 lambda minus d3 is equal to 0. Now, after writing the general formula, then we have to find out what is the d1 first by help of the d1 formula. What is d1 formula? It is sum of the main diagonal element. The answer would be 18. Okay, let us move to find what is d2. To find d2, our formula is sum of the minus of the main diagonal element. So here, as per the concept, I am going to find out what is the sum of the minus of the main diagonal element. So in my previous video, it is clearly explained how to find the sum of the minus of the main diagonal elements. So I am going to use the same concept here. After using the same concept and after simplifying, I got my result is 99. Okay, let us move to find what is d3. So we know very well how to find the d3 for 3 by 3 matrix. It is determinant A. So we also very know how to find the determinant for 3 by 3 matrix. So you just write all the elements in the determinant simple. Then as per the determinant concept, you have to simplify. Then your answer is what is your answer? It is 162. Now substitute all d1, d2 and d3 in the general formula of characteristic equation. Then our characteristic equation is lambda cube minus 18 lambda square plus 99 lambda minus 162 is equal to 0. So now step 2. In step 2, we need to find out what is the eigenvalues. So first we are going to use a calculator to find the eigenvalues. So in my I have uploaded another video for how to use calculator for finding eigenvalues. Okay, so you go to that video where you will get a clear idea about how to find the eigenvalues in the calculator. Okay, I will share the links in the description also. So now we will directly move to the eigenvalues are 3, 6, 9. Okay, now step 3. So there are two types. Suppose if we are having repeated eigenvalues, then the method is totally different to find eigenvectors. Suppose if we are having non-repeated eigenvalues, then it is same for symmetric and non-symmetric matrix. First, it is non-repeated eigenvalues. It is very easy. You just write the formula of eigenvectors. It is nothing but it is a minus lambda I into x is equal to 0. Now substitute all the results in the formula, then simplify it, then you will get this equation number 1. In equation 1, you have to substitute lambda is equal to 3 first, then simplify it. Here you have to choose two different rows and write this in a pattern. Okay, that pattern is we have to start with the second element. Then here I have chosen the first row and second row. We have to start with second element as first, then third element, then first element, then first and second should be same. Okay, first and last should be same. So after writing this pattern, then use cross rule method. By cross rule we can easily find out what is capital X1. Then similarly let us move to find what is lambda value, the next lambda value. Then find out what is capital X2. Then use next last lambda value, that is lambda is equal to the last one 3. So find out the eigenvectors in cross rule method. Therefore the eigenvector is 1 minus 1 0 when lambda is equal to 1, and minus 2 1 2 when lambda is equal to 2, and minus 1 1 2 when lambda is equal to 3. Thank you.